On me, the honor to introduce you Dr. Luca Manelli. We have been studying together. We were in this very room the morning that we uploaded our bachelor thesis together. And from then on, we a lot of water passed through through the canal.
12 years.
12 years. 12 years. A lot of time ago. And we built our careers, and especially Luca built a very successful career. He completed his PhD. He is now lecturer in forensic biology at the Bournemouth University. I guess you have your introduction, so I leave the floor to you to introduce yourself, and happy to help you.
Okay, thank you very much, Niccolo. Okay, so my name is Luca, and as Niccolo said, I studied here in this very university between 2009 and 2012, I think. So yeah, I think we graduated in this very room, at least for undergraduate degree. So that was fun. And even though now I teach in forensic biology, my background is very different. I studied the undergraduate here in agriculture and food science, and it was with Lara Maistrello, who some of you work with, some of you probably had as a lecturer. She was the person who made me passionate about the world of entomology. In second year, we had that very unit on the wall, entomology and plant pathology. And I fell in love with insects, with entomology. I found it so interesting, the biodiversity, the complexity of societies in insects, and just how we can study insects to answer questions about pretty much anything. And it was in a seminar like today that I first learned about the application of entomology to forensics, how insects can be used to solve crimes. I had no idea that was even a thing. And we had a guest lecturer from the UK, and he gave a presentation of like the one we did today. And I decided that I fell in love with this topic, with forensic entomology, how you can study insects to solve crimes, specifically murders and homicides. So I decided I wanted to continue studying that topic, and I decided to do my postgraduate degree, same university, but in Modena, and I did my postgraduate in biology. A lot of different topics, but very, very interesting. And I knew that if I wanted to continue studying forensic entomology and to do research in forensic entomology, I had to find a scholarship to do research. And after a lot of attempts, I managed to get a scholarship at the University of Winchester, which is in the UK. It's in the south of the UK. Winchester was the old capital of England back at the time where Vikings were sort of conquered most of it. So the little bit that is left, Winchester was the capital, and it was a very interesting experience. COVID right through the middle, very exciting. Not, but I managed to continue doing research in forensic entomology, and specifically, I worked with fire investigation. So when you have a victim that is involved in a fire, either because fire happened and they died because of it, but also if someone killed a victim and then tried to conceal the crime by setting fire to the room, for example. That is what I studied. And I studied how insects behave in those situations. Are they still attracted to a burnt body? Does it change the way they colonize the body, the dynamics of colonization? Do they grow differently? Do they grow faster, slower? Do they die because burnt meat can be toxic? So this was the field that I started researching. And then a year and a half ago, I started working full-time at Bournemouth University. Bournemouth is a lovely city it's a town on the south coast of England, lovely beaches, lovely place to live. And there I teach forensic biology, so it's a bit of a broader topic. It involves how we use biological evidence like plants, pollen, algae, insects, but also how other animals can interact with human bodies. And then I'm also a board member of the EFE, which is the European Association for Forensic Entomology, which is a group of about 100 people that gathers every forensic entomologist in Europe. It's a very small field. There isn't that many people that study forensic entomology. We have quite a few in Italy. We have one in Genova. We have one in Campobasso, two in Campobasso, weirdly. And we have one in Puglia and one in Milan. So there is a few in Italy as well. And just a disclaimer before we start, there will be some graphic images. We study death pretty much, so there will be some pictures of death, animal or human. I try to limit this because it's not everybody's cup of tea, but there will be some pictures, so just a warning. Now, the title of today's presentation is Post-mortem Colonization of Human Remains, blah, blah, blah. And the first word in this title is post-mortem, okay? You're Italian, most of you, I guess. So post-mortem, you know what it means, after death. Whatever happens after death is what we call a post-mortem event. And these are some of the organisms that can have some interest on a dead body, okay? We have vertebrates, we have invertebrates, we have bacteria. We have also fungi sometimes, but we're not going to talk about fungi, and we're not going to talk about bacteria. And the reason why these organisms are interested in human bodies is because a body becomes a very easy source of nutrients. Okay, as the body decomposes, it releases nutrients, and there are going to be organisms that take advantage of that situation. And now, as in every other environment, there is always competition between organisms. Okay, but our body is very interesting because we have what we define as inter-kingdom competition. We have the insects versus the vultures versus the bacteria. They all try to take as much as they can from that very rich source of nutrients, which means that you have to get there fast, which is why colonization, with colonization we mean animals using the body as a substrate for food, for shelter, has to be quick. So all these animals have evolved to be very quick at locating bodies. Vultures have very good eyesight. They can spot a body from kilometers away. Insects have very good sense of smell, so they can smell a body kilometers and kilometers away. So they had to learn how to get to that body quick. Apart from all these animals, the body decomposes itself. And the decomposition is the name we give to that process in which we observe a series of physical changes to the body. So the physical structure of the body changes, but also some chemical changes. There are going to be enzymes within our body that digest our own tissues because we don't feed anymore. So every time we talk about forensic entomology, we must start from decomposition. So we need to learn, if we put a body out there in the field, what's going to happen to that body. And it's often a similar template that is followed throughout decomposition. And decomposition is a continuous process. It's gradual. It evolves gradually. It depends on the temperature, rainfall, wind, a lot of different factors. Us as humans, we try to make sense of things by dividing them into stages. Okay, we want to break down something very complex into a lot of different stages, which is why people that study decomposition of humans or animals divide the decomposition into 1, 2, 3, 4, 5, 7, 8, 11 stages. It depends on who you're asking. But most people agree that there are about 5 stages to decomposition in normal environments. Okay, so if you have something borderline, like a body in water, or a body that's been burned, or a body that's been buried, these are borderline cases. But if you have a body out here, it will probably follow this specific decomposition pattern. Now we start from what we call the fresh stage. Okay, this is someone dies. That's the start of the fresh stage. Okay, the body is fresh. There's nothing obvious on the body that makes it look like they are dead. Okay. Then we go into the bloated stages. Okay, we're going to talk through each one of these individually, but you can guess what it means. The body will bloat. Then we go into early and advanced decay. So we lose a lot of mass when it comes to the body, up until the very last stage, which is the skeletal stage, when only bones are left. And then we go to archaeologists and anthropologists to study these. But let's take a step back to the first of these stages. Now, a fresh stage starts in the moment of death, and it stops when the body is clearly bloated. Okay? And in this stage, the person who investigates these cases is what we call a forensic pathologist, okay, the coroner. And that's because there are some signs on the body at the very start of the decomposition process that can be used to answer specific questions. When did this person die? Why did they die? How do they die? One of these you've definitely heard before, and it's what we call a rigor mortis. Okay, the body becomes rigid. You could walk on those legs and they wouldn't move because the muscles are so contracted that if you put someone's head over here and their legs on that bench, you could walk on top of it and it wouldn't move. So it's a contraction of the muscles, and that contraction follows a specific pattern. After this many hours, we're going to have this level of rigidity. After this many hours, it's going to become more rigid, and then it's going to slowly die out. We then also have what we call a liver mortis. Now you can see liver mortis in that photo. You can see that the bottom of the body is red, the top of the body is pale, white. And that's because the blood sinks to the deepest part because of gravity. Okay? There is not a heart anymore that pumps the blood around the body. Okay, so it will just slowly set to the bottom part of the body. So this is the normal situation, right? The body goes down by gravity. What do you do if you find a body that is the other way around? You will have the blood at the top and the white part at the bottom. That doesn't make sense because gravity doesn't go up, it goes down. But if I roll a body after, the liver mortis will stay as it is. It's set, the blood coagulates, it stays there. So if I move the body afterwards, I can say the body's been moved because this doesn't make sense. Gravity pulls the liquid towards the ground, not towards the top part. So we can answer questions like this using these early post-mortem changes. And then we have the algal mortis. That algal mortis is the cooling down of the body. The body is hot, it's 36 degrees, and it will slowly reach ambient temperatures, 20 degrees in here. So the body will go from 36 to 20 gradually. And that process can give us some information about how long ago was the body at 36, how long does it take to get to 20. So you can build mathematical models to try and understand what's going on. And this is all good, but this is valid for the first 1 to 2 days after death. If a body is found more than 48 hours after death, this is useless. Rigor mortis disappears. The blood will probably be digested by bacteria and enzymes, and the temperature of the body is just going to be whatever temperature the environment is at. So forensic pathologist is only really useful in the early stages after death. If we find the body slightly later on, we need to speak to someone else to get this kind of information. And in this stage is when we have insect colonization. Okay, insects, as we said, need to get to the body quick because they want to take everything they can in terms of nutrients. And the main insect attracted to body is the blowfly. Okay, this is a blue bottle blowfly. We have green bottle blowflies, and they are the main colonizers of human bodies and animal bodies in most of the world. Now, before we move on, we need to understand how insects develop. Have you all done entomology as part of your degree? So you should know what we're talking about-ish. Now, blowflies go through what we call a complete metamorphosis. They go from egg to larva, to slightly bigger larva, to slightly bigger larva, to a pupa, all the way to fully grown adult. Okay. And the ecology of those animals is very different because larvae will be the ones that are feeding on the body, whereas adults do not. The adults will only come to the body because it's a good site to lay eggs. Okay. Larvae will feed on flesh, on meat. Adults will feed mostly on nectar from flowers. So they have a very different lifestyle and dietary habits. And also larvae don't look anything like the adults. So we have a very different morphology. And then after we go through the larval stage, we go into the pupal stage. So the larva will migrate from the body, find a nice lovely site to complete their metamorphosis. No one's going to predate them. and then they will emerge as an adult and the cycle continues. Okay, so to understand how bodies get colonized, we need to understand how the blowfly evolves throughout this whole decomposition process. Now we're going back. We have a body, and we mentioned that blowflies need to get to that body quick before other animals colonize or before bacteria eat everything there is. And as we mentioned, blowflies have an exceptional sense of smell, and they can detect the gases that are released as part of decomposition from a large distance and in very small concentrations. So if we have a body on a day like today, it's very warm and sunny, blowflies will reach the body within seconds to minutes, because again, they want to get there quick before competition kicks in. And they will lay eggs, which look a bit like this, they're very tiny, usually in natural orifices of the body. So most of our orifices are in our head. So we have nostrils, eyes, mouth, ears. If we are not fully clothed, we have genitals and anus as well, but often human victims tend to be, to an extent, dressed. And this is very important. So you expect to find blowfly eggs in these areas, okay? So usually mostly around the head, okay? And that is because blowfly larvae are very, very tiny. They're like a thread, like a cotton thread. So if they lay on the skin, they will not be able to penetrate the skin to then access the flesh, the soft tissues. Whereas if they lay eggs, if they start developing in the nostril, for example, they can go inside the body and eat internal tissues that have no skin, obviously. Now, this is important to know, because what if we find something like this, okay? And this is the first question we can answer as forensic entomologists. We can determine or suggest the cause of death. Now, this is a pig carcass. They look similar to humans in their anatomy. Is there any orifice in that area where all these flies are concentrated? Normally, we don't have a hole here, okay? But maybe there is a hole there. What could that hole be if this, for example, is a crime? Could be someone got stabbed with a knife, someone could be shot, someone could have been beaten with a baseball bat, and then we have a laceration, okay? So we have an opening of the skin that becomes what we call a secondary oviposition site, okay? Now, generally, blowflies are creatures of habit, so they still prefer the head, but also they don't want to lay eggs when there is overcrowding. So if there are already too many eggs in the face, they will just move elsewhere, okay? And a wound is a very good site to lay eggs because it gives their offspring a good chance to survive and to complete their development. So if we do have an unusual colonization pattern, we can suggest there must be a reason why these blowflies colonize that body part, and the reason is likely to be some sort of wound there. So when you see this sort of red color, this is one of the applications of forensic entomology, and this is the first thing we can determine, the cause of death. Last year with my students, we had some deer carcasses that we put in the woods. The deer were shot, so they had an entry wound and an exit wound, and you had eggs and larvae feeding in those areas, okay? So you can then suggest that there must be an injury there. Now, sometimes when the body is decomposed, you can't really see what the body used to look like anymore. So you could say you can see the wound, but no, once it decomposes, it also starts to shift and change shapes. So if we see concentration of large larvae in an area, that is likely to be an oviposition site. Now, all of us, we cannot digest our food alone, right? We need bacteria that help us digest specific types of food. And we live in symbiosis, okay? We give them a bit of food, they help us digest the rest, and we live nicely together, and we evolve together to be able to optimize nutrients. Now, if we die, we stop eating. So those bacteria have nothing to feed on anymore. So they will start feeding on our own tissues, okay? And as they do that, they keep producing metabolites. They keep producing gases. And those gases have nowhere to go, okay? So what we observe is something like this. The body starts to bloat and bloat and bloat. So we have a buildup of gases that makes our abdomen become very large. This person wasn't obese. It's the same person of the previous picture. It just, the gases keep the body bloating and bloating and bloating. Not only The facial features tend to bloat as well. The tongue tends to stick out. The eyes tend to bulge. And this is very important because if you have a victim and you want to identify that victim, you might call a family member of someone who's missing someone, and they might ask you, is this the person you're looking for? And they might say no, because the person doesn't look anything like what they used to in real life. Okay, so this is one of the main limitations of this stage. And as we mentioned, this bloating is caused by internal bacteria that keep producing gases, and these gases have nowhere to go because the rigor mortis closed all our muscles, so all our orifices are tight. So these gases will keep going and going and going up until some opening creates itself on the body. It could be that the pressure is too much and it just pops. Very unlikely. More likely, the insects will start digging holes into our tissues and open that wall. Now, in this stage, this is what the body could look like. All these eggs that were deposited around facial features. If we have like folding, like this could be a good ovipositive site because it's a bit moist, it's sheltered, and the larva can not be predated. So we can have oviposition under the body, inside foldings of clothing, and so on. So after a while, it's just a big pile of maggots. Okay, and this is what you could come across. Because these larvae have an unlimited availability of food, there is no competition. Bacteria were there first, but they eat much less than these guys do. And there is so many of them commonly that the temperature of the body was going down, but now it starts to go up again because all these larvae have a very quick metabolism and release heat as part of their feeding process. So we can have 40, 50 degree bodies at this stage. And these gases that they develop attract even more insects. So we have more and more insects coming to the body because they're trying to get a slice of that food availability. Some of these are predators, as in every other ecosystem on Earth. When there is prey, there is the predator. And these are some of the predator beetles that we can find on human bodies. We have staphylinids, hysterids, and sylphids, very commonly associated with bodies. They take the larvae, take them away, eat them. But there is so many larvae that it doesn't really matter. There is more than enough for thousands of these beetles. So now we have a body with a lot of larvae feeding on it. And the second questions we can answer is try to estimate what we call a minimum post-mortem interval. How long has this body been a body? Okay, when did this person die? That is the main question that us as experimentists try to answer. And this is the time frame we're working with. Okay, we have to the right, the body is discovered. So we can find the picture you've just seen, like a big pile of larvae. And everything we know is the last time that person was seen alive. So we want to know between the moment the body was found and the moment someone saw that person last alive, we want to find within that time frame, when did the person die? And insect evidence can help us have an estimate of when that was. And we say minimum post-mortem interval because death and insect could be very close in time. So if someone dies out here in the field, within a few minutes, insects will colonize their body. So death and colonization are very close to each other. But if I kill someone and put that person in the freezer for 2 months, and then I put them outside, there is a 2-month gap between two events. Okay. So we cannot answer the question, when did this person die? We can answer the question, when did this body get colonized for the first time? Okay, this is all we can do. So if a lawyer in a court of law asks, when did this person die? The answer is, I don't know. I can tell you it was at least this many days, because these insects developed to this stage need this many days. And we know this because we have a lot of research on the field. Okay, this is all we can say. And we can say this because insects are cold-blooded animals and they develop based on the temperature they grew in. So if it's hotter, they will develop faster. If it's colder, they will develop slower. And we know pretty much how fast they grow at different temperatures. And they do this because they accumulate heat as part of their development. So they have a fixed amount of energy they need to absorb from the environment to grow and complete that full life stage. And we call these thermal units, okay, that there are a fixed amount of heat that they need to gather from the environment to complete their development. And we call these degree days. Okay, Calliphora vomitoria, one of the species that is most commonly associated with bodies, needs an exact amount of degree days to complete their development. It doesn't matter how long it takes. It could take them 5 days, it could take them 15 days, because it depends how hot it is. If it's 20 degrees, they will accumulate 18 degree days. If it's 5 degrees, they will accumulate 3 degree days. So the hotter it is, the faster they get to that energy packet they need to complete. So what we determine, usually we want to be a bit more accurate than days. We want to be saying hours. So we know that for every hour that passes, this insect has accumulated a fixed amount of heat from the environment. But let me make sense of this. This is the moment of death. This is the moment the body is found. We want to know where we're sitting on this line. Now, as soon as we get there, as forensic entomologists, but hopefully crime scene officers and the police do this as well, they place one of these next to the body. This is a data logger, and every half an hour, every hour, depends on how you set it, it collects a reading of temperature. So we know what happens to the temperature in that area, in that crime scene after death. Okay, so every half an hour it takes a reading. Okay? So we have a data set at least for the moment after death. We don't know this one because there was no data collection in that stage. But we do have around the places where we live, meteorological station that take readings of temperature every day. Okay. Now, if we're lucky, the body's right underneath a med station. It's unlikely though. Usually it's a few kilometers away because bodies are often found in woods and dodgy places. So what we need to know is where we're sitting on this time frame. Now, we don't know that yet, but we know what temperature was the crime scene after we found the body because we've placed a data logger there. And we know all of this. So the green arrows is what we know. So what we can do is we create a mathematical model to compare these temperatures. For example, let's make it very simple. I know that at the crime scene, it's always 2 degrees better than at the med station. We want to know this element because this is the temperature at which the insects grew. So if we have a mathematical model for this relationship, we can apply it to this time frame. Okay, and it's accurate-ish. It depends on the quality of the data. But then if we know what temperature was at the scene before the body was found, we can then use that data to try and recreate how much these insects have been feeding on the body for. So let's say I know that this insect is 10 days old. I can tell you this person died at least 10 days ago because these insects were on the body for 10 days. Maybe it was 20, I don't know that, but it's at least 10 days. Okay. And we can know this because we have developmental data. We know that this species, Lucida sericata, another very common blowfly, even in Italy, this is how much it takes at different temperatures. So you can see that at 15 degrees, it takes 31 hours for the eggs to hatch. But at 34 degrees, it takes 8 hours. It takes a very short amount of time. And this is what can give us an indication of how long it takes for different species to develop to the stage that we find them in. I'm going to close it here. We're not going to do mathematical regression here, but this is just to give you an idea of how it works. Okay, we just try to recreate thermal history of a crime scene and then apply that regression analysis to our crime scene specifically. Now, we were at the stage where we had a bloated body full of larvae feeding on it. And as we mentioned, at some point, the larvae will pierce a few holes between the skin and the inside of the body. When that happens, all these gases that have been building up get released into the environment. And that body that was very bloated goes back to being fairly skinny, even less so than when they were alive, because all the flesh underneath is gone. All the organs have been eaten, etc., etc. And when we reach this stage, we have still some flesh remaining. So the insects are still actively feeding on the body, but we'll get to the point where there is not enough for everyone. Okay. At the end of the early decay stage, we don't have any flesh left. We still have some tissues. We have hair, skin, bones, cartilage, tendons, but all the organs and all the flesh, the meat, is gone. So we get to what we call the post-decay stage. The skin literally sits on the bones pretty much. That's what happens. So the larvae that were feeding very actively on the body all of a sudden have nothing to eat anymore. So they call this a day and they say, we have to leave the body and we need to complete our development. So they will evacuate the body, find a nice quiet spot, dig into the soil and become a pupa. Okay, they will develop, they will literally melt and reorganize themselves into fully grown adults, and the cycle continues. Now, if you know about pupariation, after the adult has left the puparia stays there. Okay, the little lid comes off and you have an empty puparia in the soil. And this is very important because when you find the body a long time after death, there's only bones left, so you can call an anthropologist and they can tell you, you know, the sex of the victim, they can tell you the age, they can tell you broadly the nationality and so on. But there's not much else we can do. But we can still find empty puparia in the soil. And we can use a lot of fancy new techniques on those puparia that a lot of people are researching at the moment to answer questions. One of the projects I'm working on is being able to find accelerants like petrol, diesel, paraffin, and so on in the puparia that is left behind when we have fire investigation cases. So we want to know whether someone threw petrol on the body before setting fire to it. And if there is petrol, it was deliberate. Someone actively poured petrol on the body. So if you can still find those residual accelerants in the puparia, because the insect has been eating that body covered in petrol, we can then say this is a deliberate fire scene and so on. But even though blowflies have left the scene, nothing to eat there anymore, that doesn't mean that we don't have life associated with this body. And these are some of the organisms that can be associated with post-decay stages. Nicola knows these guys very well because he's working with them in the past. These are domestic beetles, skin beetles, and they feed on dry remains. So all the dry skin, the cartilage, the hair. It's food that no one else is really interested in, but they are, because they're specialized into something that there's no rush to get to. We also have some moths, Tinaida pyralida, that can be interested in those dry remains. Up until we get to the point where there's nothing else left to eat. Everything is too desiccated and dry to be eaten. We still have some organisms associated with remains. This is a mite. They can be associated with very dry remains because they're very tiny. They can get into smaller areas that no one else can get to. So you can find them associated with bodies. We talked about blowflies. Blowflies are 90% of the biodiversity of the body. Okay, but we have a lot more diversity potentially, especially in specific crime scenes. If we have a buried body, buried quite deep underground, the blowflies are not very good diggers. So you have other flies that are specialized in digging, called coffin flies, and they can get to bodies that, again, have less competition than others. I'm not going to go through these, but these are some of the families of flies associated with bodies, and then we have a whole series of beetles associated with bodies. Some of them are predators, the last three of these. Some of the other ones feed on specific types of human remains. Some of them feed on wet human remains, for example, in a bog. Some of them feed on dry remains, etc., etc. Now, let me give you an example of how complex a crime scene and an investigation around a crime scene can be. This is a case that was published, and it's a suspicious death that happened in 2015 in Guangxi in southern China. Apologies for the photos. A man was found in a park on the shores of a lake, and the man had, you can see in picture B, a large wound on the front of the skull. And we had some, picture A, blowfly eggs in the hand. Around the ear, we have some larvae that are already feeding. You can tell because of their color. We have some more eggs in picture B on the face. And then we can see, for example, I don't know how well you can see with the light, but we have some liver mortis at the back. So there's blood accumulated at the back, like we were talking about earlier. So there is no explanation to this death, therefore it should be investigated. Now, the body's still in the fresh stage. We don't have any obvious abdominal bloating. All we have is this wound on the front of that skull. Now, the pathologist came because it's a fresh body, gave a post-mortem interval estimation, and the pathologist decided that this person was dead for a maximum of 40 hours, so nearly 2 days, maximum. Can't be longer. Now, because we have quite a few insects, they called up an entomologist as well. They have more money than most police stations, I suppose. So they asked the entomologist, can you do a minimum post-mortem interval estimation as well, just to check they match? Okay. And they did. So they sampled all these larvae, identified them. There were third instar-stage larvae, so the final stage of larval development of two species that are very common in southern China. It's Chrysomia megacephala and Chrysomia rufifacius, the two blowfly species. And we have laboratory data that show us how quickly they get to each stage at different temperatures. So they did everything we talked about. They picked meteorological station data, they placed the data logger, compared it to regression analysis, and they have a minimum PMI as well. Now, pathology says 40 hours. Entomology says 68 hours at the very least. Which one is right? Who do we trust? If we need to take this case to court, what do we say to the jury? 2 days? More? So we had another question to answer: which one of these estimations is correct? Now, investigative work starts. So they started asking people around if they saw anything suspicious, and actually someone saw a man that was bleeding. He was walking around a bit confused, with a wound on his head that was bleeding actively. He was still alive. He was walking around. They identified the victim, and the victim had a history of mental health issues. They had a mental disability. And what happened in this case was that both of these estimates were correct. This person was dead for, indeed, 40 hours, but these insects have been feeding on that person for 68 hours. And that is because insects have been feeding on that person for longer than they were dead. What happened eventually was this man fell on a rock, cracked his skull. He was still alive. He eventually died for the bleeding. But because the tissues were slowly dying on his forehead, flies thought this was a dead body, laid eggs in the wound, and the eggs hatched and the larvae started feeding on that body. And this is a very specific type of forensic entomology investigation. It's called myiasis. Okay, so we have a colonization, not of a dead person or animal, but of a live person or animal, which is more common than you think. Now, eventually, this case was brought to court because this person had a mental disability. He had a carer that was supposed to take good care of him, which didn't happen. That carer was taken to court and actually sentenced because just left the person roam the park, crack their skull, and walk around for 2 days with an injury in their skull. So this is an interesting case of an application in which we use entomology to answer a more complex question. And as we mentioned, this is the definition of myiasis. Now, myiasis is specific of situation in which we have colonization of live, not even remains, live individuals, animals or people. This is another case. Again, sorry for the photos. This is a dog that was taken to a veterinary because they had a wound. Okay, and the owner said, I don't know, I found him in the garden like that. And how long was this dog wounded for? Oh, just a few hours. Okay. Now the vet's a bit suspicious, and that wound doesn't look right. It doesn't look like a wound that's been a wound for 2 hours. What's inside that wound is this. Okay. So this dog wasn't injured for 2 hours. This dog was injured for days. And again, the owner didn't take care of the dog. Okay. which because these insects, if we calculate a minimum PMI estimation of these insects, was days and days. This is a third stage larvae, so they have been feeding for quite a while on that injury. In this case, the man was sentenced for. The third application that we can use, we talked about cause of death, we talked about minimum PMI estimation. The third is abuse, neglect. And we have a lot of cases of myiasis, especially for pets, so cats and dogs, owners that don't take good care of them. We have a lot of cases on livestock, sheep mostly, because larvae also colonize feces. Okay, so if you have a wool stained with feces and the owner of the sheep doesn't clean the sheep, I suppose, we can have a myiasis going on. There is also humans, unfortunately, in this case, and especially elderly people who are locked in bed. They can't leave the bed because they don't have the mobility to it. And they get some sores under their body, piaghe da decubito. And the friction of the skin on the mattress, because they never move, causes lacerations in the skin, and those lacerations can get colonized by flies. Unfortunately, babies is another category that is impacted by this kind of dynamic, and it's people who have a baby don't take good care of them. They stay stained in their feces. Those feces get colonized by flies, and those flies slowly gain access to the body through orifices and stuff like that. So we had a case in England, actually. There was a baby that was found dead, and there were larvae that were quite developed inside their body. And again, this showed that there was neglect from the parents that eventually led the kid to death. The kid died of starvation eventually, but they could prove that not only they let the kid die of starvation, but there was a history of neglect before. These are very sad cases, whether it's animals or humans or elderly or young people, but it's very important to answer these questions. We need to prove that an animal or a person was neglected, because it makes the sentence much harsher than if just died because it banged their head on a piece of furniture. Okay, so we can, if we prove neglect, we can give a harsher sentence. Now, this is another case that is quite interesting. We had the body of a woman found in the bloated stage. Okay, so it's not fresh, it's been dead for a while, not enough to rupture the abdominal wall, but bloated stage of decomposition. And we had some colonization in the head and in the upper torso in these two blowfly species. Okay, so everything is normal. Colonization starts in the head and then works its way down. So no other injuries or anything like that. But usually when you have a crime scene or a body colonized, the insects are pretty much all of the same age, mostly. You have different groups, but in this case, there was a lot of different sizes and shapes, which was a little odd, because you have different species and different species are larger than others, and that's fair enough. But they were very confusing. Like they were larger on the face than here, much larger. So there was a lot of confusing patterns of development. So the investigators were a bit suspicious. And now we calculated the minimum PMI on the larvae that were found in the airways of the victim. And the minimum PMI was determined to be 3 weeks. This person has been dead for 3 weeks. No, this person was seen alive less than 3 weeks ago. But the entomologist is adamant this length can only be reached after 3 weeks of feeding on human remains. How is that possible then? Is the entomologist wrong? What are we talking about? Is the person lying about meeting them less than 3 weeks ago? What's going on? That's the answer. The question we need to answer. Now, what happened was, in this case, the victim died of overdose and snorted cocaine before death, and eventually probably perished as a result of that. What happened was, cocaine is an excitant. It excites us, and it makes our metabolism much faster. We snort, I don't snort cocaine, but people who are users of cocaine tend to snort it, okay? So the blood vessels in the nose will have a high concentration of the drug. And the nose happens to be one of the first places blowflies lay their eggs into. So these flies that have been feeding on the flesh inside their nose got high in cocaine, pretty much. So their metabolism went faster, they started to growing bigger and bigger and bigger, bigger than normal. And eventually, this is actually a case that was studied in the US. And it was demonstrated that cocaine can accelerate larval development. It's very important to know, because if we have a suspected drug-related death, we need to know that there is drugs, because we can be very wrong in our estimation if we don't know that. And this is a fairly young discipline. It started when I was born, 1990. I guess it's still very young, but we did studies with morphine, with cannabis, with paracetamol, ibuprofen, alcohol, and all these substances, drugs, pharmaceuticals, and whatnot, have an impact on larval development. Some of them slows it down, some of them fastens it up. And this is the fourth application of entomology. Okay, it's called entomotoxicology, and it's toxicology study of drugs, entomology study of insects. We put them together, and this is the answer. So the project I was telling you about earlier, by looking at petrol and whether it's used in a fire scene, we also know from recent work that petrol does impact the way insects develop, because it's a bit toxic. We don't love it. Okay, right. I only talked about insects so far, and the presentation is about scavengers in general. Okay, this is insects that are always present in every crime scene, pretty much. If we have a door, a room like this one, we close all doors, and we have a body in the middle of the room, they'll get here. They'll find a way. It's very, it's good enough to struggle to get to. So you'll find they'll go through the door, keyholes, little gaps in the windows. They will get there somehow. There is very few cases which don't have insects. Martin Hall from the Natural History Museum in London, he did a study with suitcases. Put a body in a suitcase, zipped it up, left it there. They found a way to get in. The blowfly laid the egg outside the zip, and the larva emerged on the other side of the zip. So they get, and they opened it, there was thousands of larvae. They found a way. So there's very few cases which you will not have insect colonization. Okay. One of them is if you bury the body very, very deep. Okay. You might have very little colonization to not. But in most cases, you do have insect colonization. Okay. Someone's got to eat that body. In some cases, not as commonly, but you do have large animals that can colonize the body, because again, it's a source of nutrients and it could be very beneficial. We have birds, we have loads of birds, crows, seagulls. Some birds have evolved to be specialized scavengers, like vultures. Vultures only eat carcass. It's the only bird that feeds entirely on dead flesh. We have birds of prey, like eagles or buzzards, so on. We have mammals that feed on human remains, lovely rat, porcupines, very weird relationship with human bodies, foxes, badgers, a lot of different organisms. We then have fish. This is a hagfish, Mycena, it's like a lamprey, like a lamprey kind of organism. Okay, it's got a very lovely mouth, as you can see. Less commonly, we have reptiles. Okay, this is Southern Heath monitor. It's like a varano, similar. Okay, they've also been observed feeding on human remains. Now, what happens is blowflies. There are a lot of them, but each of them eats a very little amount of flesh. These guys can eat quite a bit. Okay, in fish, I could put a shark. Sharks are known to feed on human remains. It doesn't take as long for them to skeletonize the body. But all these different vertebrates can have different types of impact on the body, and also how that their activity, their actions can impact us as investigators on that body. And these are the three potential ways that vertebrate colonization can impact our investigation on the body. They can create injuries to the body. So a simple bite can cause an injury that could be mistaken for a perimortem injury, like an injury that happened around the moment of death, like a gunshot wound or a stab wound or a laceration of the skin. They can accelerate decomposition, and then they can create injuries that then insect can get through to. Or they can remove body parts. These are the three ways they tend to impact how a body decomposes. Now, starting from the first one. Now, normally, some vertebrates like to feed on very easily accessible human remains. Okay, so they can do the same thing that insects does and focus on natural orifices. Okay, but also we mentioned those alterations. It can be like a scratch, it could be a bite, it could be some vertebrate trying to rip away part of the body. We can mistake these for events that happen around the moment of death again. So we need to be able to determine which ones are, we call them peri-mortem, around the moment of death, or post-mortem. We need to tell which ones are which one were caused by a potential suspect and which ones are caused just by animals in the area. And some of them are surprisingly similar to alterations caused by weapons, for example. These, for example, these are sea lice, and they can cause injuries like that. They look a bit like shotgun pellets, okay, like a fucile. Okay, and we need to be able to determine these are actually caused by, in this case, an invertebrate rather than a firearm, for example. Okay, but again, bites could look like potential stab wounds, for example. So, like a large carnivore, imagine a bear. It's got big canines, can penetrate the body and leave a mark that could be mistaken for a weapon. And don't only think of like a fresh human body, think of a skeleton. You can have a skeleton with markings on the bones that we need to give an explanation to. And a lot of these organisms can have an impact on that. Then we talked about decomposition. Now, if we create a new opening on the body, that opening is a good substrate for insects to colonize, but also for bacteria to colonize. We have bacteria in the environment that equally are interested in the body because it's rich of nutrients. So we can accelerate the decomposition. The decomposition is faster than it would be without. But also we have some animals that are not interested in the body, but they're interested in the larvae. So they can just keep eating the larvae, which would slow down the decomposition process. This, for example, is a victim that was found outdoors, and he had scratch marks all over the body. And some of these scratch marks were lacerated, so we had eggs laid inside those wounds. And this was a raccoon that just tried to something interesting for it to the body. Now, if the composition slows down or accelerates, again, we need to know that because they can have implication for our estimation of how long that body's been dead for. Okay, because we have previous knowledge on how bodies tend to decompose, lose mass. And then we have removal of body parts. Now, this is very important because often families of the victims want that full loved one. They don't want just an arm. They want a full body. And there are specific religions that, for which this is very important, to have an entire body that is buried, for example. But also sometimes to identify the victim. If we only find torso and arms, it's very difficult to identify that person without a head, for example, because we identify human remains by teeth, so dental patterns, facial features if they're still fresh. So if you don't have a head, for example, it's very hard for us to identify who this victim is. And especially mammals, but also birds, sometimes like to take body parts and take them away. Think of an ancient documentary when you have hyenas. Hyenas try to grab something and run away before the lions get there. So they will remove body parts and feed on those body parts far away where no one can bother them. Without having to go to Kenya, in Europe, foxes are the main responsible for this. They love ripping body parts away from the body. And they can transport these body parts even kilometers and kilometers away to their den, for example. So having a knowledge about where these dens are, for example, is important because we want to try and find the body parts. But also sometimes we can find human remains that are also colonized by insects. So we can also study the insects on those body remains that are detached from the body. Or we can find just larvae roaming around because they dropped from the body when it was moved around. We also know that, for example, seagulls like to take body parts and take them to their nests, which are usually very hard to access. Very new research that there isn't much about. But the final goal is recovering the body. We want all the body, one, to give it to the family, but two, because every body part can give us some crucial information. Imagine someone dies because they get shot in the arm and we have bleeding and the person dies. If the arm is then moved away from the body, we're not going to be able to find what caused death. So we need all body parts to have a good picture of what happened. Now, birds, for example, we mentioned, some of them like to feed on soft tissues. So they've got a beak, they just peck some soft tissues and remove them from the body very early into decomposition. So when the body's still fresh, remove body parts that are easily accessible, not too much effort, and it's a source of nutrients. For example, eyes, tongue are the most commonly associated with this. And this pecking creates laceration injuries that are often serrated, like a knife. If a knife is serrated, it's got like little waves like this, it causes a specific type of damage to the skin. But so do they, because their beaks are also serrated margins. And this is an example. This is a deer carcass, and you can see that the eye is missing because, again, easy to access, soft. And they tried to pull the tongue out, but it didn't manage to. Okay. So is this some sort of satanic ritual, or is it just simply a bird that's been feeding on that eye because it was there, easy to access? But also, all of a sudden, that hole is perfect for them. It's a new oviposition site. Okay. Now, if you find this, so this is a body that is early decay, it's starting to lose mass. You can look at this and say that's a gunshot wound. This person's been shot. No, just a bird. Okay. So all these organisms work together to get rid of as much body as possible. So some birds, like crows, like seagulls, like buzzards, so they only focus on soft tissues, and then they're not really interested in the body. But some other animals, like the vultures, are specialized to feed on carcasses, and they like to eat quite a bit of the carcass. So they like to tear the carcass apart and feed on large areas. So they like to disarticulate the body, so like the arm comes off and other body parts comes off. So again, body recovery challenges. And they can completely skeletonize a body in hours, potentially, if we have something like that. It's a question of hours. So we lose a lot of potential evidence very quickly. But they also leave significant lesions through the skeletal part of the body. Here we have a puncture caused by the beak of a vulture, which again, is this a gunshot wound? Someone got shot from underneath? No, it's just the frenzy of feeding, trying to compete with all the other vultures, caused that specific mark. But other birds like to remove parts from the body just because. For example, magpies, gadze, they like shiny things, so they might take jewelry or other elements away from the body. So it's not a robbery, it's just they just took some elements from the body away. Other birds like to take other body parts, like the hair, just to make their nests. They just straw, pile it, take it away, put it in a nest. It's nice and soft, cozy. So it's not a violent act, it's just animals being animals. And in urban environments, we have rodents, okay? And this, don't only think of rats, poor nasty rats. Squirrels are also very famous for attacking human remains, mice, porcupines, and so on. And the weird thing these animals do is what we call bone hoarding. Porcupines, for example, love bones. They don't eat them, they just like to take them and accumulate them. So often porcupine nests, we call nests, is that a nest? Or dens, they found loads, piles of bones, like little bones, like from the hand and stuff like that. Just like to take them to their den, and there's piles of human remains inside their dens. Why? We don't know. But there is a case where they found a porcupine den, and there was human remains from different bodies, from different species. They just loved bones and liked to hoard them. So very interesting information there. There's loads of different people at this den. Why? And rats do it also to an extent, but much less. But rats tend to, rats like to sharpen their teeth against hard surfaces, and the bone is perfect because it's not too hard, and they can leave very significant marks on the bone. You can see here how deep it can go, and we need to be able to understand what caused that mark. Is that a weapon? Is that an animal? So for us to have a good picture of the case, we need to understand where the damage specifically comes from. But in terms of mammals, leave the badgers, the foxes, the rats, the worst of the mammals when it comes to alteration of human remains, is a much nastier creature. It looks like this. Okay, dogs are the #1 mammal scavengers of human remains. Not just dogs, all the canids, coyotes, wolves, and so on. Mostly dogs. And it's mostly because they tend to live indoors. Okay, indoor there is a limited amount of food. So if the owner of that dog dies, what are they going to eat? Okay, so we have lots and lots of cases in which we have damage to the body caused by activity of dogs. They like soft remains, so as soon as the body becomes a body, as soon as the person dies, they like to feed on soft remains. Okay, they like. But also, as you know, dogs like bones. So they are interested at the start of decomposition and at the end of decomposition. And also, especially in outdoor environments, they like to spread the body around because they rip it apart, play with the body, and they can again relocate it elsewhere. And this is a very interesting case to showcase what we were saying here. There's a case in Spain, in Barcelona, 2013, and squatters find a mummified body in an apartment. Now, squatters are people who occupy a building that looks like no one's there. Okay, we're just gonna take this building for ourselves. They find a mummified body indoors. Okay, and they call the police because they found the body. And the deceased is the 90-year-old woman, and the investigation starts. How did this woman die? Why did it die? When did it die? It's mummified, so we have a very specific type of decomposition. It means that the air was very dry, it was fairly warm, and so on. And we had a lot of damage, apart from the mummified remains, in the ventral thorax and in the pectoral girdle, so like the scapula, clavicular, chest. Okay. So what caused that damage? If the person just died because they fell, they hit their head, they wouldn't lose all this flesh potentially. So what caused that damage? Okay, did it decompose? Is this an injury? What is it? And also there were some body parts missing. The right upper extremity, so the forearm was missing, the right foot was missing, and the head was missing. Okay, where is it? Okay, very complex situation. Like we need to find all these elements because we cannot explain what happened without all these elements. Now they find these other body remains in another room. Okay, well, how did he get there? You know the answer because we just looked at it. Because of that was highlighted quite immediately. The victim had osteoarthritis, and there was a perimortem fracture of the femur. So they fell, broke that leg, and just bled out basically. Okay. But then we still have all this flesh that is gone for some reason. So where did it go? And now analyzing the bones, because that's what we have, they found some signs of animal scavenging. Something got to this body before it mummified. But what? We're indoors. How did any animal, like a rat, get access to this place? And actually, looking at the bones, there were some V-shaped punctures from a canid. Okay, now, it's very likely to be a wolf in an apartment in Barcelona. So, dog, maybe. And also found dog feces around the apartment. And they eventually analyzed those dog feces, and they found bones within the feces. Okay, so there was a dog here, and that dog fed on their own. And eventually, the squatters remembered that actually they did find a dog body in the house. They just threw it away before they found the one. Just didn't want it there. So this is a good example of not only consumption of human remains by dogs, also dismemberment, so the removal of body parts that are then transported away. Indoors, there's nowhere to go, so they were in the next room. But if we were in an outdoor setting, we have cases of wolf activity that take the bones 30 kilometers away. So searching for those remains becomes quite difficult. We then have fish. Okay, obviously we're moving to water environments. Now, everything is different in water environments, especially in marine environments. If you remember from entomology, what's the only environment on Earth where insects are not present? Is the sea. Okay, so we don't have specialized insects that live in sea. But we also don't have scavengers that live in any water. We don't have insect scavengers in fresh water either. They didn't evolve to feed on that kind of substrate just because they specialized in other areas. But when it comes to fish, we have two main categories of fish and how they can impact the body. You can have some large fish. There's a tiger shark. Is that tiger shark? They can obviously feed on a body fairly significantly and remove most soft tissues within minutes. So they can completely skeletonize a body in a very short time frame. Or we have some more likely to be found fish that are smaller, they can feed on only some body parts. This is a cookie cutter shark, a smaller species of shark, and they can feed on soft tissues like toes, earlobes, facial features, and they can cause specific wounds that, again, we need to be able to identify because we need to know what happened to that body. There isn't a lot of research on fish. We have a lot of research on how fish decomposes other fish or marine mammals like whales, but we don't have a lot on humans, simply because it's very hard to research. You need to put a body very deep into the sea and study how it decomposes. You need to have aquatic webcams and so on. Very few laboratories have thought of this equipment. So we need to know more about how bodies decompose in water in general. But stepping away from vertebrates for a second, we have aquatic arthropods as well. Okay, so crustaceans are, if you don't mind me saying this, the insects of the sea, right? They're close relatives, and they specialize, they thrive in mostly aquatic environments. And again, we don't have a lot of data when it comes to marine environments. The only study I'm aware of, they put pig carcasses, large pig carcasses, very deep underground. I think they did 30, 60, and 90 meters underwater. And they had like very fancy webcams. They could study how the body was colonized by crustaceans. And there were some fish that were feeding on the body, but again, most of it was crustaceans. You can see some different species of crabs, crayfish, lobsters, and whatnot. Okay. It's a rich source of nutrients. It doesn't move. It doesn't run away. You don't have to predate it. Easy accessible. Why not? What about freshwater? Now we have crustaceans in freshwater, and we worked on this quite a while ago, 10 years ago. The question was whether in freshwater systems, crayfish, Ambrose clarkii, which is an allochthonous species that comes from southeast USA, is it interested in bodies in water? Now, Ambrose clarkii is probably still is a big problem for freshwater ecosystems, just because it's a very successful species in terms of reproduction, in terms of adaptability to different environments, and adaptability in terms of diet. They can feed on live animals, decaying animal remains. So we wanted to know whether if we had a victim in a freshwater system, would this species interact with the body? Would it remove any body mass, and would it cause any injuries potentially? And the answer is yes. This is a photo that we took on the first day of the experiment. We had those round lobster pots in water with some pigs inside, and this is a single pig. And on the first day, there were 115 freshwater crayfish, which was about this size, feeding on the body. They were getting in through their mouth, anus, trying to get to as much fresh tissues as possible. But most importantly, after a few days, they were leaving significant injuries to the pig itself, which again, if we are finding the body in this condition, we need to be aware of what caused those injuries. Is this a result of the reason why the person is dead, or in this case, animal, or is this a post-mortem scavenging sign? Again, what they do is they try to pierce the skin to then get inside the body and feed on softer tissues. Now, a larva doesn't have the strength to pierce the skin, but crayfish is about this big, finds it quite easy. Okay, So multiple lacerations, round margins, which again could resemble, for example, a stab wound, but then when it bloats from stab becomes round. And again, we need to identify that this is not a peri-mortem event. It didn't happen when this animal or person died, but it happened afterwards. And they also like to pull away organs from these orifices. So they like to remove the intestine from the body because it was easier to access. This is on day 4. We had some massive lacerations on the skin, which again, one, it accelerates decomposition because all of a sudden other crustaceans can get inside the body and feed directly on tissues. Also, we have bacteria, we have different types of organisms that can benefit from these lacerations. And on day 8, we were in post-decay stage. We only had very marginal remains of flesh, of skeletal remains, and in 8 days, the body was basically gone, completely dismembered. But if we're in a water system, the body can either sink or float, right? And what we observed is the body started sinking because it was heavy, but when it started bloating, obviously the air is light, it started to travel towards the surface. Now, all of a sudden, even though we're in a water environment, we also have exposition to the air. And when we do have exposition to the air, we have our old friends, the blowfly. Okay, so in the area just above water, they started laying eggs, which you can see here. Okay, because all of a sudden it's not a water environment anymore; it's above water. And you can see that after a few days, we have a nice carpet of maggots only on the bit that is above water. Now, as we mentioned, after the bloating stage, the skin ruptures and all the gases leave the body. So all of a sudden, the body does this again. So all these maggots unfortunately die. They don't swim, and the body starts going back to the bottom of the pond, for example. So accessibility to the body in this specific case changes because we have a sunken body that immediately floats and then is sunken again. So how do these different organisms, in this case, we have a competition between crustaceans and insects, they're going to switch sort of activity between these different stages of decomposition. Obviously, in water systems, it's slightly different because we don't have only insects and vertebrates, we have also other vertebrates. Now, this is a 2-hour talk about something I usually do in 40. Okay, so try to cram as much into this as possible to try maybe spark some curiosity on something specific that you might want to develop in your own career, on your own time. Okay, there is a lot more to what we talked about, a lot more complexities, but this is just a way to showcase the potentials of studying how animals, whether it be vertebrates or invertebrates, can be beneficial to us as investigators on crime scenes. Okay, I'm a forensic biologist, so I focus on these aspects. Then you have all the other disciplines within forensics, from fingerprints to firearms to whatever you want. But biology in particular is everywhere. Okay, whatever environment you're in, you will have some kind of either bacterial or insect or vertebrate colonization. And for us to be able to understand what happens in the ecosystem called body, because the body after death becomes an ecosystem, it hosts different organisms and different communities. To understand that complexity means that we can understand everything that happened around death or after death. And understanding what happened around death and after death is what gives us answers that we can give to police or the crime scene officers to help the investigation and eventually help bring in a potential suspect to justice or to close a case because it was purely accidental. We're talking about murders and homicides, but a lot of times people die just because they die. They fall and bang their head, have a heart attack, and it doesn't matter to blowflies or vultures or fish what caused the death. They will just see the body as an ecosystem. So we need to differentiate between homicide, violent death, accidental death, natural death. Okay, and you can apply everything we talked about today, not only to humans, because investigators tend to investigate humans, but to animals as well. There is research on these same techniques on elephants, for example. Elephants are vulnerable species, protected internationally by CITES, and we can try and catch, for example, a poacher someone that kills that animal for their ivory, using the same techniques and the same knowledge that we use for humans. Okay, so the applications are infinite. Use that for whatever. In Canada, they're using forensic entomology to investigate deaths of bears, because we have poachers that kill bears for the gallbladder, because the bile in the gallbladder is sold to Chinese markets for traditional Chinese medicine. And it's a crime because the bear has got some level of protection. So we can use the same techniques for different potential cases. We have cases of suicide, cases of murder, cases of rape. We can also investigate using entomological evidence, etc., etc. Cases of neglect, we mentioned, drug trade. What else? That's it, probably. There's probably a few some more, but yeah, we can investigate a whole plethora of cases, not only human, but also animal, using knowledge around how different organisms interact with the body. And on that note, this is a photo we took a few years ago in Nonantola study for Campus Clarkey. It was very, very interesting. This is a photo from my PhD when we're looking at burnt bodies and how colonisation occurs on burned bodies. And then other two fields that I've been developing recently is animal scavengers. This is a photo, for example, of canine mandible. And if you study the distance between the two canines, you can tell what species caused the punctures. Is this a wolf, a dog, a coyote? And then diatoms, freshwater algae that can be used to determine whether a person drowned or not, if they're found in water. So if there's anything, any area of research that you'd be interested in developing or working with, these are my contacts. Feel free to reach out. It would be great to set up some networks with other people with similar interests. So feel free to reach out. And in the meantime, this is all from me. If you have any questions or curiosities, feel free to ask. Italian or English, it doesn't matter. And then, yeah, my pleasure to be here again in this very room.
Yeah. And they know I had this medical visit in Modena, and they made me lose a lot of time over there. But yeah, thank you very much. I think it was really great, really interesting. I think that there are possibly many questions that can arise. So, for example, one question that probably, because also some of these people are my students, and I mentioned them about the possibility to find evidence of an homicide where you do not find the cadaver. Is that possible to find that evidence?
So what you can do is, if you have relocation of the body, so let's say someone gets killed out here, the body's left there for a while. After a few days, the perpetrator decides, actually, it's in plain sight, I want to hide it, I'm going to take it to my car, take it to a house I have in the woods and dump it there so no one will find it. Now, we could find larvae here, still present at the scene. We can find larvae in the car that has been used to transport that body to another location. And then we have the location where the body is actually. So we can still find, if you find entomological evidence with no reason to be there, blowfly larvae are not associated with any other ecosystem than a body. So if you have larvae without a body, red flag. There was a body here, it's not here anymore. Where did it go? It doesn't necessarily mean that someone moved it. Again, it could be our friend the fox that took it away. But there's no reason why these blowflies could be here. Other cases could be if we have a skeletonized body and the bones are removed or they're washed away, like you don't have to have some sort of weird animal moving them around. Let's say it's an incline and it rains, the bones can be washed away. And we might have puparia in the soil that are protected from the rainfall, moving bodies around. So you just need to understand what potential dynamics occur around. Again, I'm not a forensics expert. I studied biology the rest of my life, so I'm just applying biological knowledge to a different setting. And if you understand the behavior of the animal, you understand and you apply that to criminal investigations. But it's just pure biology and ecology and behavior, really.
Yeah. Any question from you, or even yes?
Is there any difference in the composition of insects that do feed on, let's say, human bodies and animal carcasses?
There is, mostly because We are strange animals. We don't have any fur, for example, most of us, most body parts, whereas you have animals that are very furry. So blowflies can use hair as a potential site for reproduction. They lay under the hair because it keeps a bit protected. But we have insect species that specialize in large animals, for example, elephants. We have specific species that if you go to the savannah and you have an elephant and then a suricata next to a meerkat, the species will be different because some species evolved to focalize on small carcasses and some species focused on large carcasses. The ones on large carcasses probably develop faster because they need to get there quick before large scavengers come around. So you have size, you have composition of the body, fur, no fur. We have the environment in which the body lives. Blowflies in tropical forests are different to blowflies here. So we do have evolution. Blowflies through evolution pick a specific type of substrate to focalize. We mentioned we have flies that specialize in varied bodies because they're the only ones that can get there. So they pick their niche and they decided that's our go-to food substrate. We do know that if you have humans, if you have a baby human and an adult human, we're going to probably find different species. But a baby has a very little flesh. So it cannot sustain a large population of blowflies. They need maybe 2 weeks to develop. So maybe quicker development blowflies will focus on a smaller carcass potential. Like a Lucilia, which is much faster developing than a Califera, will pick a smaller carcass.
Any other question? I do have some curiosities. For example, about your, because I heard you, because I was connected online, although I was on the bicycle, but I heard you. So you mentioned that your PhD was on forensic entomology on burnt bodies. So yeah, what are, you mentioned maybe that is toxic or not. So what happens?
So the study was on 2 separate routes. One was burning. So you can burn a body just a bit. You can burn it a lot. You can completely turn it into coal, basically. So the first part, probably the most interesting part, was degrees of burning. Mm-hmm. We have a body, like if there is a fire in this room and we have a body on the floor, the body will not be severely burnt because the fire will develop on the walls, goes up. So the body will be very dry, and it's called a smoke death. It doesn't die because of the heat, it dies because of inhalation of toxic gases. But the body doesn't look particularly burnt. It's just a bit like grey. The hair might be burnt off. And so this is what we call CGS-1 degree burning, and that's smoke death. So in this case, we would have less insect colonization because insects like moist areas, whereas a dehydrated body is not as good of a site to lay eggs. So we can see a delay in colonization and less specimens on the body. On the other hand, if it's a smaller room and the flames go to the body, they will turn in black. And the heat will split the skin, which again, as a stab wound, it's an easy access for blowflies. So bodies that are burnt a bit more have a faster decomposition because we have more insects to it. And this is preliminary information I already knew before I started. My focus was to check whether if you have different degrees of burning and we put the same species on it, do they grow to the same extent? And the answer is no. No. Just like we had a PhD student here studying the effect of burnt flesh on cancerogenesis. Mm-hmm. And we know that burnt meat is cancerogenic. So it also has a bad impact on blowflies. So they will grow smaller if they feed on burnt remains. 1, because those compounds are toxic. 2, because the proteins are denaturated. So they will grow smaller than if the body was fresh. So that's very important because if we calculate the minimum PMI on length, we're going to have a wrong result at the end. Yeah. And then the second line was on accelerants. You know, if I have a body and I douse it in petrol and I burn it, most of the petrol will evaporate, but there will be some residual accelerant on the body. And if blowflies feed on that accelerant, is it good for them? Let's say I douse the body, but I don't set fire to it because someone is coming around, so I run away, the blowflies will die because the petrol is just too toxic for them. But if it's burnt off, most of it, they will survive, most of them, but their development could be different. And we've seen that, for example, oilers accelerants like paraffin, slows down decomposition, but water-based hydrocarbons don't have really a big impact because probably it's not enough for it to back them. But again, we want to know whether oxarin was used because we can give to the police information. Yes, and if we find, we know that petrol is not something that the larva wants, so we'll just store in the cuticle. And the cuticle turns into a puparia at some point. So if we find residuals of hydrocarbons in the cuticle, we can obtain one. It's qualitative, so we don't know how much petrol was used, but we know it was used. And so we can tell that oxarin we used, therefore it was deliberate. But also we can, okay, this is an hypothesis that we're going to look into, we can find the chemical fingerprint of the petrol. So we can tell this is Shell petrol, for example, compared to co-op. This is an open question, we don't know the answer, but that's the hypothesis.
Yeah, basically. Wow. And
because they use chemical fingerprint of petrol for environmental disasters. So there's an oil spill, we know exactly where that oil came from.
Yeah, of course.
But then if it burns off, it's easy. Probably
Yeah. And moving, I'm very curious because although, I've been listening to seminars, but what he said is really also to me very new. So, for example, also you mentioned that, there are flies that can go and excavate until what? Actually, that.
I think coffin flies go about 60 centimeters. 60. That we know. There's not a lot of data, but they try with 60 and they get there.
60 centimeters.
Blowflies are not very good. I think they're too large. So they go about 15 centimeters they can get to. So if it's very shallow grave.
So coffin flies, they're named coffin flies because you can find them inside the tombs, right? So actually these flies, it means that they are able to get inside. I mean, can you imagine what they can do? Because they need to provide, a good substrate for their, for their babies. So it's really amazing what they can do.
They're very small flies. They can easily go through the cracks in the soil to get there. And then the larvae feed on it. And then they pupate slightly up so they can leave the contact.
And another potential case, but of course, now I'm just, thinking and being curious. But of course, if you have any curiosity, he's here and please ask. So, for example, if it is summertime or even not summertime, because already, and you have a body, it was killed, this man was killed, and can you eventually understand if there are mosquitoes in the room? Can you eventually understand who could be, the person who killed the body?
There's one case that did something similar, as in they found a mosquito splashed against the wall. So it got killed against the wall in a suspect's house. And they extracted the blood from the mosquito abdomen. They analyzed the DNA of the blood, which matched the victim that was found kilometers away. So there's one case. Yeah, because if the blood is fresh, it's got DNA, it's got preserved. DNA is easy to extract from blood. So
can you believe that? So you cannot be a perfect killer because the insects will tell the truth.
In this case, the victim was at the suspect's house, was killed there, and then he was moved to the woods. So then they found the body in the woods. There was a suspect. There was someone they knew the victim. Went to their house. Someone had a very clever idea to, look at that. Very tiny microscopic amount of blood left, obviously, because it dries out quickly. You have to be quick.
You have to be quick, of course. You have to be quick, but
It degrades quite quickly.
Yeah. So, any other curiosity?
And on that note, you can extract DNA from larvae. So you can check what they've eaten before. So if you find a larva here, you can extract the content of their stomach, check for DNA, might still be there. So you can match a potential body that it came from.
Yeah, the case of was in Trona, in Campobasso, the case they found in Puglia, right? In that case, it was not on the larvae, it was on the puparia, right?
Yeah, I don't know.
Yeah, but anyway, I saw another question.
Another question. You mentioned that cocaine enhanced the development of larvae. Is there any study on drugs, effects on drugs on larval development?
There is studies for morphine, ecstasy, cannabis, very small cannabis, paracetamol, so like painkillers, normal painkillers, ethanol, so alcohol. Yeah, and a lot of them, opioids tend to accelerate development unless they are like, I think morphine isn't very good for larvae, it's a bit too much. And so it has the opposite effect, but cannabinoids and opioids, like, they're excitants, so they accelerate metabolism. So they will grow bigger. But they can give us, instead of being saying 7-day BMI, can tell us 14. They're completely off track. We don't know that. And obviously we can, if you have a fresh victim and you can analyze, you can use toxicology to try and find the drug in the bloodstream normally. If the body is decomposed, the blood is not blood anymore, it's just a goo. So you can't use toxicology anymore, but you can extract, again, the gut content of the larva, the content of the stomach, extract the chromatography, and you can find the drug inside the body of the larva. This is actually very common nowadays because it tends to, again, it's toxic to the larva, so it will just accumulate in the cuticle. So it will stay inside. It will not die because of it, but we can find what drug it was just by extracting the gut content, spinning it, mass spectroscopy techniques, and we can say, we cannot say whether they died because of the drug, because I could do cocaine and then get hit by a car. I didn't die because of the cocaine, but I took cocaine. So we cannot say how much cocaine they took, but we can say they took it.
Another question, talking about toxicology. So is it possible to understand that if somebody that is found dead was killed using a specific venom? Because I'm thinking, because, okay, maybe we are in the countryside and there is a husband who killed the wife, and he's in the countryside, and maybe he used as a venom insecticide. So what would happen in that case? Would you see?
There is some studies on insect repellent and solvents like bleach. You can use bleach to clean a crime scene. And you can use insect repellent to try and prevent colonization. So we had delays in colonization when insect repellent was used, but post-mortem. If you killed someone with insect repellent, so the insect repellent is in the bloodstream, colonization will happen, but there will be an effect on the larva, but I'm not sure what it might be. I'm sure someone must have.
But if somebody is killed with an insecticide, so the result is that maybe that the body will be colonized, but probably the larvae will die, right?
But also, if it's in the bloodstream, it depends how much they use. If it's in the bloodstream, if the concentration is too high, probably yes. The concentration might be quite low. It also depends how the chemical property of the insecticide, how quickly it degrades through time. So the toxicity halves. So it depends. There could be a delay again. It could be that they go like, smells wrong. I'll wait a second. But we also know people did use in the past insecticide on the body because they knew
about the flies.
So they tried to stop it, but insecticide evaporates. But you can get a wrong PMI, and it can lead you to forget them.
Wow, very fascinating, right? Although some of the pictures were kind of, but yeah.
I give much worse stuff to my students.
You're much. So what are you working now, especially?
So my main project at the moment is finding accelerants in puparia.
Okay.
That's the main project. But we want to do some development in cold temperatures because England is cold a lot of the year, and a lot of studies do warm temperatures because it's fast. You can get a paper quick. But slow temperatures, it takes forever, but we don't know, we don't have any data. So when you actually work on a case, you can't base your result on 15 degrees, volumes are fine.
And that is something that you think. So these flies, they are in the environment, even during winter, right? So these Diptera, they have a resistance to cold, which is like much higher than many other insects. So even if you have somebody killed during winter time, it is very cold, you still can have colonization by insects.
All you need is a good day. It's a bit warmer. So every species has a base temperature below which they will not be active. All we need is to be above that base temperature. And Califera Vomitoria has a base temperature of 2 or 3 degrees.
Ooh.
So all you need is a moment in the day where it's still 3 degrees. And all you need is to go out, lay their eggs, and then go back to where they were. And inside the body, it will not be 2 or 3 degrees. It will be a bit warmer, especially there's a few of them. You can have 2 or 3 degrees in the air, but inside the body is 15 because there's a lot of them moving around and creating heat. So all you need is a good day. Whereas some other blowflies, they don't want to live above 9, below 9. So they're specific for summer. They're fast and very fussy though. So.
Yeah, and another possibility. So if somebody is killed, for example, here in Reggio, and they don't find nothing, but then they figure out that they find a cadaver which is not in Reggio, but it is the same person. So what can you say about, for example, the history about, how did the body, for example, it was up in the mountains in Modena.
Yeah. So we have some type of geographic. So one of the other potential questions to answer is location. It's not super common, which is why I didn't include it. But for example, you can find, let's say, we live in the south coast of England. If you have a body washing ashore, is this person died like on a boat just off the coast, or did they come from somewhere else? Obviously, we have a lot of, as you do in the Mediterranean, we have a lot of migrants dying, trying to cross the channel from France to England. A lot of fall in the water and die, and then they wash ashore. So you could say, you can try and find where this person died based on what flies colonized it. If a migrant died, or a person died on the north coast of Spain, and then they traveled from the Atlantic to England, and you find Spanish species that are not present in the UK, this doesn't work. So it has to come from somewhere else. And then with altitude, we have differences as well. We have blowflies that only live at sea level or just above. We have blowflies that specialize in higher altitude. We have flies that specialize in urban environments like cities. We have flies that specialize in rural, like farms. And we have flies that specialize in forests. So you can, if you find a city species in a forest, this person didn't die in the forest. This person died in a city and then it was moved to the forest. So you can find some sort of connection. It's not tight. You can't say definitely died in the city, but you can lead the investigation to look in transportation of this body, because Musca domestica, the woods, no.
No, you cannot really find it in the woods.
It's just associated with synanthropy. So you would be, if you find like 1 or 2, it's fine. Like, but you find a large population, that's
okay.
So the body was moved. We have latitude. Yeah, we don't have the same species here as in Thailand. Completely different, tropical, temperate. But also, if you have a body in Reggio Emilia, you cannot use data from Germany to investigate this body, because biologists study variation, and different countries have different genetic populations, and they will be a bit different. So UK species, UK specimens of the same species as Italy will develop differently. They will tolerate cold a bit better than the Italian ones, and they might grow faster when it's colder than the same region. So you have to base your analysis on local populations, possibly as close as you can.
So the typical graphs that you use, they need to be actually from.
Because like Venice and New York are the same latitude, but you can't use the same data. It's just
because the populations are different, and because the adaptations.
Because when these flies last were together was a few millennia ago, so they went their own way. So it's important to have databases for every area if you want to use that in investigations.
And okay, so any curiosity, any other curiosity? No? So are you sure? Take advantage that he is here. If you have any curiosity, even in Italian, don't worry. If you don't want to speak in English and you have a specific curiosity, go ahead and talk in Italian. You sure? You sure? Okay. So again, thank you really, really very much. Very, very interesting, and I think also insightful, because I think that personally, but I think probably also you can get inspiration. And so, like he said his story, which I know very well. So he fell in love with entomology at my class, but definitely he fell in love with forensic entomology when our common friend, Professor Stefano Vanil from the University of Genova, he came and gave a seminar on forensic entomology, and that's how his love for this topic started. And of course, he made a career out of it. So maybe this is also insightful for any one of you.
One thing that I say to my first year students all the time is that throughout university, you might realize at some point that you're not really that interested in what you're doing, maybe. But I changed direction many times, and you can still change direction as long as the passion for learning something is there. So I started from agricultural insects, then I went to forensic, forensically important insect, to dogs eating people's faces. So it's a path that it doesn't have to be linear. So if you change your mind throughout your career, there's always room to sort of specialize in something different. So as long as you have that interest in learning, developing the new skills, if you ever find yourself being like you're in the wrong place,
Yeah,
it's very refreshing to know that you can still make changes to your career.
yeah, of course. And it is important to find what passion is, what is really your passion, what you like a lot. Once you find this, then you are okay. Okay. Thank you really very much. So Letizia, I see that you're still there. So shall we finish the registration, the recording?
I think it's Enrico that is running the recording, and I would like to remind you, please, to share again the QR code for the survey.
Okay, where is the
Thank
QR
you.
code? Okay, this is it. Okay, you can use it.